Hello everyone, this is Subhashini GS pursuing BE Computer Science and Engineering in Sedu Institute of Technology, Madurai. This video is about the neural network in machine learning. Let's get into the topic. Here comes the agenda of this video. In this video, you will learn about what is a neural network, architecture of a neural network, types of neural network, backpropagation in neural network, Bayesian network in neural network, and applications of the neural network. Have you ever wondered how our brain works? There are chances you read about it in your school days. Artificial neural network is exactly similar to the neurons work in our nervous system. If you can't recall it, no worries. Here is the best tutorial with real-time applications. So let's get into the topic. Neural networks are the most popular machine learning algorithms today. The invention of these neural networks took place in 1970s, but they have achieved a huge popularity due to the recent increase in the computation power, because of which they are now virtually everywhere. In every application that you use, neural networks power the intelligent interface that keeps you engaged. So, what is your neural network? Neural networks are a special type of machine learning algorithms that are modeled after a human brain. That is, just like how the neurons in our nervous system are able to learn from the past data, similarly, the artificial neural network is able to learn from the data and provide responses in the form of predictions or classifications. An important advantage of neural network is the fact that it learns from the example datasets. Most commonly, usage of artificial neural network is that of a random function approximation. With these type of tools, one can have a cost-effective method of arriving at the solutions that define the distribution. In order to understand the workings of the artificial neural networks, let us first understand how it is structured. In neural network, there are three essential layers: input layer, hidden layer, and output layer. Input layer is the first layer of an artificial neural network that receives the input information in the form of various text, numbers, audio files, and image pixels, etc. In the middle of an artificial neural network model are the hidden layers. There can be a single hidden layer, as in the case of an perceptron, or multiple hidden layers. These hidden layers perform various types of mathematical computation on the input data and recognize the patterns that are part of. In output layer, we obtain the result that we obtain through rigorous computations performed by the middle layer. In a neural network, there are multiple parameters and hyperparameters that affect the performance of the model. The output of artificial neural network is mostly dependent on these parameters. Some of these parameters are weights, biases, learning rate, batch size, etc. Each node in artificial neural network has some weight. Transfer function is used for calculating the weighted sum of inputs and the bias. After the transfer function has calculated the sum, the activation function obtains the result. Based on the output received, the activation function fires the appropriate result from the node. For example, if the output received is above 0.5, the activation function fires as 1, otherwise it remains 0. Some of the popular activation functions used in artificial neural networks are sigmoid, softmax, tan, etc. Based on the value that the node has fired, we obtain the final output. Then, using the error functions, we calculate the discrepancies between the predicted output and resulting output and adjust the weights of neural network through a process known as backpropagation. There are two important types of artificial neural networks: feed-forward neural network and feedback neural network. Feed-forward artificial neural networks. In the feed-forward artificial neural networks, the flow of information takes place only in one direction. That is, the flow of information is from the input layer to the hidden layer and finally to the output. There are no feedback loops present in this neural network. These type of neural networks are mostly used in supervised learning for instances such as classification, image recognition, etc. We use them in case where the data are not sequential in nature. Feedback artificial neural networks. In feedback artificial neural networks, the feedback loops are part of it. Such type of neural networks are mainly for memory retention, such as in the case of recurrent neural networks. These types of networks are most suited for areas where the data is sequential or time dependent. Backpropagation in artificial neural networks. In order to train a neural network, we provide it with examples of input-output mappings. Finally, when the neural network completes the training, we test the neural network where we do not provide it with these mappings. The neural network predicts the output and we evaluate how correct the output is using the various error functions. Finally, based on result, the model adjusts the weights of the neural network to optimize the network following gradient descent through the chain rule. Bayesian networks in artificial neural network. These type of neural networks have a probabilistic graphical model that makes use of Bayesian interface for computing the probability. These type of Bayesian networks are also known as belief networks. In these Bayesian networks, there are edges that connect the nodes representing the probabilistic dependencies present among these type of random variables. The direction of effect is such that if one node is affecting the other, then they fall in the same line of effect. Probability associated with each node quantifies the strength of the relationship. One is able to infer from the random variables in the graph with the help of various vectors. The only constraint that these networks have to follow is it cannot return the node through the directed arcs. Therefore, Bayesian networks are referred to as directed acyclic graphs. Applications of artificial neural networks. The following are the important artificial neural networks application. Handwritten character recognition. Artificial neural networks are used for handwritten character recognition. Neural networks are trained to recognize the handwritten characters, which can be in the form of letters or digits. Speech recognition. Artificial neural network plays an important role in speech recognition. The earlier models of speech recognition were based on statistical models like hidden Markov models. With the advent of deep learning, various types of neural networks are absolute choice for obtaining an accurate classification. Signature classification. For recognizing signature and categorizing them to the person's class, we use artificial neural networks for building these systems for authentication. Furthermore, neural networks can also classify if the signature is fake or not. Facial recognition. In order to recognize the faces based on the identity of the person, we make use of neural network. They are most commonly used in areas where the users require security access. Convolutional neural networks are the most popular type of artificial neural networks used in this field. We studied how neural networks are able to predict accurately using the process of backpropagation. We also went through the Bayesian networks and finally we overviewed the various applications of artificial neural networks. Thank you.